Welcome back from the ad break, and let's continue with our lesson. So now we are going to go into the first focus of our lesson, and that is multiplication of polynomials. We are going to start here with multiplication of monomials with constant monomials. When we multiply a monomial with a constant monomial, we multiply the integers together and keep the variables as they are. So for example, let's simplify the following expression. I have the 3 multiplied by 6x. So what are we going to do here? We are going to multiply the integers. That is 3 multiplied by 6, and that gives us an answer of 18. And then the variable, we are just going to leave it as it is. So my answer there is 18x. Let's look at a second one. I have the negative 8p cubed multiplied by 5. So again, what are we going to do? We are going to multiply our integers. So that is a negative 8 multiplied by 5. That gives me a negative 40. And as for the variable, we are going to leave it as it is. This is when we are multiplying a monomial with a constant monomial. Let's look at more examples. Let's simplify the expressions. So we have there 4/5 multiplied by 3f exponent 8, and this is divided by 2. So how are we going to multiply that? So we are going to be multiplying 4/5 and multiplying it with 3/2. So what is 4/5 multiplied by 3/2? Yes, if you are thinking of 12 tenths, then you are absolutely correct. And what happens to that variable? We are going to leave it as it is. But now, remember, when we are working with our fraction, we need to always make sure that we simplify that fraction. So we are going to look for the highest common factor between 12 and 10. And what is the highest common factor between 12 and 10? If you are thinking of 2, then you are absolutely correct. So this means that we are going to divide the numerator by 2 and also divide the denominator by 2. So 12 divided by 2, that is going to give us 6, and 10 divided by 2, that is going to give us 5. And of course, we have the f exponent 8. So there we have 6/5 and f exponent 8. Remember, this is now an improper fraction, so we need to fix it so that it becomes a proper fraction. And how are we going to do that? We know that 6/5 is the same as 5/5 plus 1/5, right? And we have that with the f exponent 8. And what does that become? We know 5/5 is the same as 1, and we have the 1/5. So we have 1 and 1/5, and we have the f exponent 8. Let's look at a second example. We have the 5g multiplied by 1/2. So 5g multiplied by 1/2, that is going to be 5g divided by 2. Or now we have 5/2. Next, we are going to be multiplication of monomials with non-constant monomials. When we multiply a monomial with a non-constant monomial, we multiply the integers together, and then we multiply the variables together by applying exponent laws. Now, as a reminder for those exponent laws, remember that if we are multiplying powers of the same base, then we are going to add the exponents there. So for example, let's simplify the following expressions. So now we have 4a squared multiplied by negative 9x cubed. So what do we have there? We are going to say 4 multiplied by a negative 9. That will give us a negative 36. Now we look at a squared and x cubed. They are not the same base, so we are going to just write them as they are, and that is going to be a squared and x cubed as our answer. Let's look at a second example. So I have there 2h exponent 5 multiplied by 6h squared. So we are going to start with the integers, and that is 2 multiplied by 6. That gives us an answer of 12. Now, if we look at the variables, they have the same base. So these powers have the same base, and then we are going to now add the exponents. So that is going to be an answer of 5 plus 2 is going to be 7. So our final answer is going to be 12h exponent 7. Let's simplify the following as well. Again, as a reminder, if we are multiplying the same base, then we are going to add those exponents. So now we have 5y exponent 4 divided by 2, and we are multiplying this with 7y. So again, we are multiplying 5 halves, and we are multiplying that by 7. So 5 halves multiplied by 7 gives us a total of 35 halves. And when we look at the variables, we have a variable with an exponent 4 and the same variable with an exponent 1. And when we multiply the same base, then we add those exponents. So 4 plus 1 is 5. Then we have negative 3q cubed multiplied by 12q cubed. And what are we going to do? We're going to multiply the integers, that is negative 3 multiplied by 12. That gives us a negative 36. And then we have q exponent 3 multiplied by q exponent 3. Same base, we add the exponents, so that is going to give me a q exponent 6. So our final answer is negative 36 q exponent 6. So what about when we are multiplying binomials with a constant? So when we multiply a binomial with a constant monomial, we multiply each term of the binomial with the constant and keep the variables as they are. So here I'm going to remind you of the distributive law. So remember distributive law, or the distributive property, if we have a number outside of the bracket, then it is going to multiply with each of the numbers or the terms inside the bracket. So we are going to multiply that, and that is 5 multiplied by 9. That is going to be 45. And the variable, we are going to leave it as is. And our second product is going to be our 5 multiplied by 1/5. So remember, we are subtracting, so that is going to be 5/5. And as we know, 5/5 is 1. Next, we are going to say a negative 6 multiplied by 2p divided by 3 plus 12. So we are going to distribute that, and that is going to be now a negative 6 multiplied by 2/3. Now negative 6 multiplied by 2/3 is going to give us a negative 12/3. And we are going to leave the variable as it is. And then now we are multiplying a negative number with a positive, because in the brackets we are adding. So a negative, when we multiply it with a positive, that is going to be a negative answer. And that is going to be now negative 6 multiplied by a 12. We know that our answer there is going to be 72. Right? But because that fraction needs to be simplified, or we can just say, what is negative 12/3? That just gives us negative 4p and minus the 72. Right, let's continue. Let's move on to multiplication of trinomials with a constant monomial. So when we multiply a trinomial with a constant monomial, we multiply the constant with each term in the trinomial, and then we leave the variables as is. So let's look at an example. We have the 4, and this 4 is going to be multiplied by 3x squared minus 9x minus 2. Again, this is a reminder of our distributive property, because that 4 must multiply with each term inside the bracket. So we are going to say 4 multiplied by 3, that is 12, and we leave the variables as they are, that is the x squared. Then 4 multiplied by 9, So that will be minus because we are subtracting. 4 multiplied by 9 is going to be 36 and x. Then we are subtracting again. Then we are going to say 4 multiplied by 2, and that is going to be an 8. And that is our answer for that expression. The next one there, we have 1/12, and this is multiplied by 6h squared minus 7h plus 4. So 1/12 multiplied by 6, that is going to be 6/12. And we leave the variable as it is. Then we are subtracting 1/12 multiplied by 7, that is 7/12. And the variable will remain as is, and that is going to be now 1/12 multiplied by 4, and that is going to be 4/12. And the first term there and the last term, they can be simplified. So when we simplify 6/12, that is actually equals to 1/2, and we still have the h squared. We minus 7/12, that can't be simplified any further. And then we add, when we look at 4/12, we need to simplify that. Remember, the highest common factor there is 4, and that one simplified will be 1/3. So the final answer there is 1/2 h squared minus 7/12, I actually forgot the h there, plus 1/3. Let's continue to multiplication of binomials and trinomials with non-constant monomials. So when we multiply a binomial or a trinomial with a non-constant monomial, we multiply each term of that binomial or the trinomial with the monomial and apply exponent laws when multiplying the variables. So just as we've been doing with the previous ones as well. But now we have a binomial or a trinomial. Let's look at an example. So we have there 5x squared multiplied by 2x minus 1. Again, we're still going to use that distributive property. So we are going to multiply the integers first, and that is 5 multiplied by 2. That will give us a 10. But now, x squared multiplied by x. They have the same base. We remember our exponent laws. That means that we are going to add the exponents. So that is going to give us a 10x cubed. Then we are subtracting. Then we say 5 multiplied by 1. So 5x squared, multiplied by 1. And that is going to be a 5x squared. And that is going to be our final answer. What about when we are multiplying with a trinomial? So same method will apply. We are going to use the distributive property, and this term outside, or this monomial outside, is going to multiply with each term inside the bracket. So now we have a 7 multiplied by a 1, because that is 1p cubed. That is going to be a 7. Now we have p cubed and p cubed. They are being multiplied, so we add the exponents. That is going to be p exponent 6. Then we are subtracting. We are going to multiply 7 multiplied by 5. That is 35. And the p cubed multiplied by the p is going to be p exponent 4. Then we are going to add the 7p cubed multiplied by 3. 7 multiplied by 3 is 21. And the variable, we are just going to leave it as it is, and that is a p cubed. So that is how we multiply either a binomial or a trinomial with a non-constant monomial. Let's quickly go to an ad break, and then we'll see you just now.